Today, we're going to be talking about how satellites work. There are two types of satellites, natural and artificial. The planet Earth has one natural satellite, and that natural satellite is the Moon, which rotates the Earth once every 27.3 days. Artificial satellites are manufactured and transported into space by a rocket. Satellites are placed at specific altitudes in space. Their altitude depends on the service they are providing. The closest a satellite can be to Earth is 160 kilometers or 100 miles. This is the beginning of the lower Earth orbit. The lower Earth orbit region extends from an altitude of 160 kilometers to 2,000 kilometers, with satellites providing services for weather, navigation, and broadband internet. Now, the Earth rotates in a counterclockwise direction at a speed of 1,670 kilometers per hour or 1,037 miles per hour. Now, the lower space orbit resides between 160 kilometers above Earth, which is represented by this line, and 2,000 kilometers above Earth, which is represented by this line here. Now, in this area here is where we have all your lower space orbit satellites between 160 and 2,000 kilometers. So most satellites reside at the 400 kilometer altitude. Now, the rotation speed of these satellites is 28,000 kilometers per hour. They can be in a clockwise direction or counterclockwise direction. The International Space Station also resides in this area. And by the way, the International Space Station is categorized as a satellite. Now, it rotates the Earth at the same speed of satellites in this area at 28,000 kilometers per hour. Astronauts on board of the International Space Center would actually experience sunrises and sunsets every 90 minutes, which is amazing. Now, satellites in this area are used for weather, navigation, telephone, and broadband. Now, the broadband part here is quite new. This got started in 2019. Companies like SpaceX are actually working on this right now and to provide this service around the planet. What they're doing is trying to provide broadband internet for underserved communities around the world. Remote communities that currently do not have internet right now will all have internet once this project is completed. Now, of course, we have had internet from satellite in the past, but the problem was it's coming from the geostationary satellite at an altitude of 35,000 kilometers from the Earth. And as a result of that distance, there's a lot of latency in getting in the Earth. At a distance of 400 kilometers, you shouldn't have that degree of latency. So it would be quite interesting when it's all completed, because it's supposed to be just as fast or even faster than cable internet. So now we're going to be talking about the medium Earth orbit, which starts at an altitude of 2,000 kilometers, which is represented by this line, and it goes up to 35,000 kilometers, which is represented by this line here. So in this area here, we have the medium Earth orbit. Now, most satellites in this area reside around the 20,000 kilometer altitude from Earth. Now, at 20,000 kilometers, the rotation speed of the satellite is 16,000 kilometers per hour. Now, as you can see here, an altitude of 400 kilometers, the speed was 28,000 kilometers per hour. So as you can see, as we move away from Earth, the rotation speed becomes less. So the rotation speed is much slower at 20,000 kilometers versus 400 kilometers. Now, the medium Earth orbit area is primarily used for global navigation, GPS, and also scientific research. And here we have the geostationary orbit. Satellites in this orbits at 35,786 kilometers from Earth. This is probably the most crowded area for satellites. It has services like long distance telephone, television, data, and broadband internet. One thing I want you to take note of right here is that the satellite speed is the same as Earth. At this particular altitude of 35,786 kilometers, any satellites within this area at this altitude rotates at the same speed as Earth. Remember, the medium Earth orbit was 16,000 kilometers per hour. Earth was only 1,670 kilometers per hour, so the rotation speed was a lot more than Earth. The rotation speed for the low Earth orbit was 28,000 kilometers per hour. But with the geostation orbit, it's at the same speed as Earth. The advantage of this is, let's say for instance, you were standing on Earth and you look up towards the sky. You probably won't be able to see a satellite, but let's say you had some really powerful telescope and you were able to look out into outer space and you looked at that satellite. That satellite would be stationary. There wouldn't be any movement at all. It would look as if it is not moving. And the reason that is because Earth and the satellite are both moving at the same speed. So it would appear to you as if it is not moving at all. But if you were somewhere else observing both Earth and the satellite, you will notice that the satellite is in fact moving around the Earth. The advantage of this is that it is communicating to a specific area on Earth. So whatever area it is communicating to do not change at all. 365 days a year, it is always in the same spot. So you don't have to adjust the antenna, you don't have to do anything. This is the advantage of communicating with a satellite in a geostationary orbit. Now, broadband internet services work in this area. I mean, it's great for emergency areas, or it's great for someone who just got to have internet who lives in a remote area. But the service is not great. There's a lot of latency, and it is more expensive than the typical cable or DSL service that you may get. So that is why we have broadband internet services now being developed within the lower Earth orbit, because there will be less latency at 400 kilometers from Earth versus 35,000 kilometers from Earth. This is Trevor from Telecom Training. If this video has been helpful to you and you would like to see more videos like this one, please don't forget to like and subscribe.